Hello, welcome to session 3 of the Lawson Fuses Fuse Masterclass. Last time I talked about the construction of a fuse link and how important the sound was. Today I'm going to talk about the rest of the components within the fuse link assembly. So refer to the image on the screen. Fuse body or barrel. Most bodies are now ceramic, but a very specific type of ceramic that is specially designed for high strength. The body needs to withstand the massive energy levels being applied. The ceramic mixture needs to be consistent between each batch, so every barrel is near enough identical with no hairline cracks or lesions within the material. The density of the ceramic is routinely checked to make sure the composition is the same between each batch. Let's talk about elements. Elements are another crucial part of the operation of a fuse. All fuse links will have one or more elements, usually a copper strip or a silver strip, sometimes a wire. Some of the larger readings have more than 30 elements. The elements are precision cut from copper or silver foil to ensure they give the same performance characteristics for each fuse link. The image shown shows a typical element. All of our elements are tin plated. Each element has a different shape with different restrictions or constrictions cut into it. Generally, the shape in the middle is for the small overload protection, and the shapes at either side of this are for the short circuit protection. You can see the low melting point alloy on the element. That allows the diffusion process to take place and melt with the effect of an overload. We do use a laser cutter when we're doing R&D work, but all production parts are machine pressed and cut. In manufacturing, all of the elements have to be fitted in a certain way, and every fuse link for a particular current rating has to be exactly the same. This means the control documentation and operating instructions must be very detailed and very clear. We'll go into further detail of how we control the manufacturing in a later session. End caps. These are generally copper or brass, which are then plated with either tin or nickel. Many fuse links will have an inner cap. This is fitted directly to the ceramic barrel. It is the inner cap to which the elements are attached. An outer cap is always fitted so that connection can be made to the electrical system. The outer cap may be blank, like household cutouts, or we may connect a tag to the outer cap to suit the application of the fuse link, for bolted connections, for example. It is interesting to note that the inner cap is connected to the barrel purely by an interference fit. The outer cap is fitted to the inner cap purely by interference fit. With standard circuit barrels, there are no screws or bolts to attach the caps, just a push fit. That is why the engineering of the metalwork is so important. It needs to be very accurate. There are some very interesting calculations in the design and manufacturing process. The end result is that the components must not be able to be pulled apart. For small current readings, we still use ceramic barrels but omit the inner cap and make the interference fit of the outer cap directly onto the barrel. The element is jammed between the barrel and the inner cap, creating a good mechanical and electrical connection. Another important part that is often not talked about is the heat disc. A heat resistant and an arc resistant disc is usually placed between the inner and outer caps. This helps to control the arc formation when a fuse link is operating in reaction to a short circuit fault. The material for this disc is suitable for extremely high thermal insulation. Okay, fuse tags. These parts are generally always copper, which is then plated. The tags are attached to the cap by a number of different methods. A mixture of different types of rivets, orbital riveting, clinching, brazing and soldering. Each component is assessed individually to give the best mechanical connection and the required thermal and electrical conductivity across the whole fuse. Don't forget that each HRC fuse will also be filled with sand. Okay, you've now seen the full internal construction of a fuse link. There are many different varieties, but the construction is always very similar. I hope you find it interesting. Don't forget to follow, share and comment, and I'll see you next time for the next session. Thank you. Bye.